Well, good morning. It's Friday, 5/29/20. Today, we're going to look a little bit at the atmosphere. All right? So, what I want you to be able to do is I can name 4 layers of the atmosphere and tell me, something important about each one. So, now what is the atmosphere? We have the Earth, and we think of the Earth as kind of the solid parts. There's some liquids, but there's this just thin, skinny little layer of gases over the top. And Earth has enough gravity to hold on to this little bit of atmosphere. Planets that are much smaller than the Earth have a hard time holding on to their atmosphere because they don't have enough gravity. And planets that are bigger than the Earth, the atmosphere gets crushingly dense. Okay, so we're pretty lucky where we are. So, just the scale of things, if I have the Earth, and the Earth is about 8,000 kilometers in diameter. So I have this ruler scaled out so that there's one of these units would be 1,000 kilometers. And to think about where stuff happens, literally, if you are about this far above the Earth, you're considered an astronaut. We don't think of that. I mean, the pictures that we see usually of satellites and orbit and stuff are misleading. Most satellites orbit, about this far above the Earth. So if we were looking from a distance, it looks like the satellite's just skimming across the top of the Earth or over the surface of the Earth. And for all practical purposes, it is. And it's not that far. In fact, I don't think any of us would think too much about getting in the car and driving for an hour. No big deal. But if you drove for an hour upward, you'd be an astronaut. We're talking at, 50 miles an hour. If you go 50 miles above the surface of the Earth, the United States considers you an astronaut. Now, most of the world is using metric, and most of the world takes the standard of 100 kilometers, which would be more like 62 miles, I think. All right? But U.S., 50 miles, they consider you an astronaut, which means just 50 miles up, the air is so thin that for all practical purposes, we ignore it. Wow. All right. Why is the atmosphere important? Well, you need to breathe, right? And the atmosphere is kind of this reservoir of the gases we need. So you and I need oxygen. Hey, about 21% of this stuff is oxygen. And so every time I breathe in, I'm taking a little bit of oxygen in. Now, you and I give off carbon dioxide. So every time I breathe out, there's a little bit of carbon dioxide. Now, if you happen to be a tree instead of a human being, the tree is taking in carbon dioxide from the atmosphere and giving off oxygen as waste. And so the atmosphere serves as this reservoir and exchange of these gases that are necessary for life. What else is the atmosphere? Cosmic radiation. There are stars out there, including our own sun, that are just blasting off huge amounts of radiation every second of every day. And without our atmosphere above us, we would be cooked. Flat out. We couldn't exist here. We talked about how the oceans moderate temperatures. Well, so does the atmosphere, okay? Because anytime one part of the Earth starts heating up, those gases start expanding and moving around, and it stirs the planet, and it moves heat around. So the planet is overall a little more uniform in temperature than it would be otherwise. If you are on Mercury with no atmosphere, if you're on the daytime side, I think the temperatures in the sun there approach like 800 degrees Fahrenheit. And then if you are on the nighttime side, temperatures approach, I think, like negative 200, 300, 400 Fahrenheit. You have basically 1,000-degree difference between night and day on Mercury because of the atmosphere. Here, pretty typical for us is about 20 to 30-degree difference between night and day. Okay, you wake up in the morning, morning might be low 50s, afternoon, maybe 70s. 25-degree difference, pretty normal. not 1,000 degrees. Water cycle. Okay, we evaporate water. Where does it go? Into the atmosphere. And then it rains back down on our heads, and we get, nice rain to help us grow our crops. Hopefully not too much, hopefully not too little. That's what we're always hoping for. And hey, without the atmosphere, I couldn't be talking to you right now. My sound wouldn't travel. All right, I'm going to skip over this for right now. This is talking about the gases oxygen and carbon dioxide. I'm going to try to keep this video a little bit short, just show you a few basics. Oh, ozone layer. Remember I said to keep, the atmosphere protects us from harmful radiation. Well, some of that radiation is called ultraviolet. And there's, UVA and UVB and I think UVC. And the ozone layer is this layer of the atmosphere that has ozone molecules in it. They're produced from other reactions in the atmosphere. And that ozone layer is really good at absorbing some of those high energy ultraviolet rays. And so if we have an effective ozone layer in the atmosphere, not very much of that UVB gets to the surface of the earth. And if more of that are getting to the surface of the earth, we have a lot more problems with skin cancers and all sorts of things. Once in a while, a rock from space hits the earth. I mean, it hits the surface of the earth. Now, literally, rocks from space, mostly really tiny, are hitting the atmosphere all the time. But the atmosphere burns up most of them. So we don't have a surface that's pockmarked and cratered like the moon or the surface of Mercury. Most of it doesn't hit the surface of the earth. Okay. So, I think I'm going to use this diagram because I think you can read it better. We're going to divide our atmosphere into 4 layers. And the basic criteria for these layers are what's happening to temperature. So if you look at this layer, here's the surface of the earth. And during this bottom layer, here's temperature, okay? So here's the warmest temperature on this side, the coldest temperature. And so as you get higher above the earth, so this is 10 kilometers up, you see the temperature really plummets in 10 kilometers. So we're saying that right down here on the surface of the earth, we might have an average temperature in the 50s. And when we get up here 10 kilometers up, the temperature tends to be around, I think that says negative 78 or negative 76. It gets pretty cold as you go higher, right? But then, for whatever reason, and to save time, I'm not going to get into the reasons, I'm just going to say these are the distinctions. When we get to this layer of the atmosphere, as you go higher, the temperature climbs again. Not exactly balmy. I mean, we're talking about, it gets back up to about 0 degrees right here. And, this is kind of almost the edge of space, so it's not like it's very, even though the molecules may have that kind of energy, there's not very many molecules around, so we still can survive. Then we get to another layer where the temperature goes down with altitude. And then we have one more layer where the temperature goes up with altitude. And you see this temperature skyrockets, which means that the individual molecules have incredible amounts of energy up here, but there's almost no molecules. So there's still not enough total energy for us very well. Okay? So what are these layers called? This bottom layer is called the troposphere. And I'm going to just tell you a couple of things. What's important about the troposphere? This is where we live. That's pretty important to us. The troposphere is this bottom layer of the atmosphere. It's only, 10 kilometers thick, a little over 6 miles thick. This is where the weather happens. Okay? really, truly, the stuff that kind of matters to us most in our day-to-day lives about the atmosphere all happen within that first 10 miles above us. Well, there is more up there, but it gets really thin. So this next layer is called the stratosphere, and I'm going to say what is, maybe one key thing you can remember about the stratosphere, and that's where we find the ozone layer. And that's pretty important, protecting us from the ultraviolet radiation. When we get way up higher to the mesosphere, this is where the meteors burn up for the most part. Okay? And then this really thin outer part, which we would honestly consider, again, if you get this high, we consider you to be an astronaut. Okay? But space doesn't just start. I mean, the atmosphere doesn't just end and you're in outer space. What happens is the atmosphere gets thinner and thinner and thinner as you go up. And so there's very, very, very thin atmosphere up here. And it is enough to interact with rays from the sun and create the auroras. So the northern lights, the southern lights, the aurora borealis, the aurora australis, those happen, they take place up in that thermosphere. So we have 4 layers: troposphere, closest to the Earth; significance, it's where we live, it's where our weather happens; stratosphere, that's where the ozone layer is; mesosphere, we had mesosphere in the Earth, now we got mesosphere in the atmosphere. Meso is just kind of a word that means in between. So mesosphere, that's where the meteors burn up, and thermosphere, that's where the auroras happen. And that's as far as I'm taking it for today. Have a great weekend.